Hello, I am Clement, Chief Architect and co-founder of Wavefront. I'm here to tell you about distributed tracing. We're super excited to announce the availability of distributed tracing support in Wavefront today. And now, if you're coming in from an open source project such as Zipkin or Jaeger, you probably are no stranger to distributed tracing. But if you're new to distributed tracing and want to know a bit more, I hope this video will help you to understand a little bit more why distributed tracing is such a powerful tool to debug, analyze, monitor, and troubleshoot your applications. But just in case you did come here because you're used to Jaeger and Zipkin, I want to let you know that the Wavefront system, the Wavefront proxy specifically, can actually just take the data that you're collecting today with Jaeger or Zipkin and just have us manage that in a SaaS platform. And you don't have to deal with scalability. You don't have to deal with issues of retention. And we just basically take the management aspect of storing, visualizing, and alerting on traces from you so that you can concentrate on building applications and managing your infrastructure. So with that, I want to talk about kind of distributed tracing. But instead of talking about distributed tracing in the context of applications, I just want to use an example of how distributed tracing could really apply to kind of any situation in real life. And let's say it's in the morning and it's 7 a.m. and you decided to get out of your house and you wanted to take a ride. Let's say you want to take a Lyft ride to work that day. And let's assume the first thing you do is you walk out of your apartment, and then you pull out your phone, and then there's some kind of the phone calls some back-end service, and it tells you like, okay, the car is going to come back 5 minutes, and you said, okay, cool, I'm gonna call the Lyft ride. And then you kind of stand there again, wait for about 5 minutes. And then during that time, the car actually come over to you, and you're on your way. You're on your way to work, and as part of that journey, the system is constantly phoning home, telling the system where we are, kind of the estimated ETA, and then finally you get dropped off, and then you finally are at work. So you're done at work, and it's kind of like, let's say it's 7:30 a.m. All of this can actually be modeled as a distributed tracing problem. You have a single, I don't want to say transaction, but you have a single activity that's going on, and you globally want to identify this with a single unique ID. And in the context of distributed tracing, it's called the trace ID. So you could imagine, let's use this example and just say, this is your November 15 morning commute, right? That's your trace ID, and all of the things that happened, whether it's pulling out your app, whether you're pressing the button to get a ride, whether it's you're pulling out your app and the driver app is phoning home and telling your ride company where you are, as well as you're getting dropped off and getting charged. All of that relates to a single trace, and in this particular case is your November 15 commute. And you can see there are many pieces already in this kind of distributed trace, right? It's something that's happening in particular on your phone. There's something that's happening in particular to some sort of a ride finding system. And then there's something that actually calls the driver, right? And then there's another app that's involved, and that's the driver's phone. And then finally, there's a transaction that happens that actually talks to your credit card company that actually charges probably the pre-authorization, right? So all of these small bits of actions that comprise this entire trace is what we call spans. So in traditional parlance, all of this are typically just globally unique IDs. But in this particular case, you could imagine this is the phone. And then you have a ride service going on, and then you have the actual calling of the driver, and then you have the actual ride, and then the credit card authorization, right? So imagine why you want all of this in a single system such as Wavefront, and it's because you want to figure out, let's say something is wrong with your credit card authorization at the very end of the journey, right? That's kind of the worst case, because you kind of pre-authorized the credit card, and then you're actually not getting, the company or your business is actually not getting paid, Right, so what you can actually do in Wavefront today is to bring all of this disparate actions, again, analogous to spans, associated with a single trace into Wavefront, and Wavefront helps you visualize that. And the most common visualization that you would have is a timeline. So a very typical view is what we call an icicle view, where you see a global trace, or there may not even be a global trace technically, but just all of the bits of actions that are related to that entire activity. And Wavefront visualize that in a single place and identifying the different components or services that are related to the entire action. Again, this is your morning commute. And let's say there's a particular problem that's going on, which ultimately may have propagated upwards to an error message to the phone, right? So the final step is you getting off and you basically seeing, how was your ride and all that kind of stuff. But if the charge didn't go through, it might actually come back with an error, a nasty error message. But that error message may be deep down, meaning it's because of a backend component that's failing. And so you could drill through into that particular span. I'm trying to kind of expand this particular section here. And you can actually see it is actually a particular span that's having a problem. And with distributed tracing, you could add annotations to a single span. So it could be, OK, well, this is an authorization to, let's say, Visa. And you have some sort of an auth code that's going on. And maybe you could even have a line number that indicates the problem that's in your code and any diagnostic information there. So all of that is percolated upwards, maybe ultimately as an error message to the user. But this enables you to drill down very quickly and find out, oh, it's actually credit card authorization. Maybe in this particular case, it's a problem with a payment processor. And you could actually then figure out, what is the best course of action to take. Now, distributed tracing is powerful compared to traditional APM because, as you could see, it could be something that spanned, in this particular example, 30 minutes. But it could also be something such as order shipping. For example, somebody place an order, and that's a single activity that's going on in your application or in your business. And maybe the shipping action actually happens a couple of days later. And if you want to model it that way, you could do that in Wavefront and see the entire trace in the system. What you could also do, especially with what Wavefront is offering, is to take in our open tracing compliant interfaces as well as open census compliant interfaces and have your own traces be injected into the system. So for example, let's say you're a Go developer and there's a particular path, you're not making an external call, you're not really calling an Amazon service, but there's a function that you're calling and you really want to know how long is it taking, what are the users that are involved in that function. And you could emit that through the interfaces that we provide, either directly emitting it to Wavefront or through open tracing, through open census. And we'll gather all of that up. And again, remember, as long as it's within a trace ID, as long as it has a trace ID, then we could group all of that together so that you can see the results. Now, one of the interesting things with Wavefront is not just for us to provide you this view of a single activity, but we also provide aggregated information about how things are actually interconnected. So imagine you could have a system where people are just joining your company, trying to understand, what's really going on with the application. How is this flow happening on a day-to-day basis, and how many times are people, having problems with a particular payment processor? How long are people spending, waiting in their car, getting to their places? And how often are people calling a particular, pressing maybe a particular button and ending up with a ride? All of that information is what we call metadata that we could aggregate on top of all the span information. And oftentimes that's presented as a topology view, as a causal view, as a time spent kind of view. And we are just scratching the surface currently at Wavefront on what we can do with that data. And we're happy to announce today that we have an ability to provide a complete inventory of your service, as well as to provide a preliminary service map of how things are internet connected together. We definitely expect to have a lot more data because of all the enriched information that's being sent into Wavefront, and trying to give you the best possible visualization of how things are interacting together, where trouble spots are happening, where hotspots are happening, and where you should be even spending time optimizing performance because a particular area of your code is slow. So hopefully you get to try it out. We have an SDK, observability SDK, that you could drop into your application, and you could start emitting traces immediately to the SaaS platform, and you could then look at your spans and your traces. Hope to talk to you guys soon. Thank you.